Okay, so this is part 3 of Unit C. Here is the homework, questions and answers, if you need those from the previous lesson. Okay, randomized block designs. These are a really good way to do it. When you're doing an experiment, if you don't want to do just a completely randomized experiment, blocking is really good for when you have similar groups. Oftentimes you might block by gender, boys and girls. You might block by grades, 9th, 10th, 11th, 12th. If you have some type of similarity that might make them a student or a participant to answer differently, blocking. It's similar to stratification, but stratification is with observational studies. It's a sampling. This is a method of an experiment. So we call it randomized block design. And so you carry out the treatment, complete treatment, separately in both groups. So you actually have control and the treatment in the group, in each group. So this is what it might look like. Let's say your assignment to blocks is not random. Okay, so that's important to know. We block with a purpose. So here is an example, the effectiveness of the size of the field used for growing blackberries. So maybe there's 10 spaces, and some are more fertile, they're closer to the water, some are further away from the water. Notice in this case, it wasn't exactly equal. It doesn't always work out equal with blocking, but it's nice if it did, but it didn't in this case. So we block into 2 separate groups. Now, in each group, we actually do a full experiment. So we do random assignment. Half the people in that group get the treatment, half get the placebo. Half get the treatment, half get the placebo in the other group. And then we compare the yields. So here's an example. Some popcorn lovers want to determine if it's better to use popcorn button. So there's actually a button in your microwave that says popcorn on it, or to use the recommended time that the popcorn bag says. To measure how well each method will work, they will count the number of unpopped kernels remaining after popping. That makes sense. To obtain the experimental units, they buy 10 bags each of 4 different varieties of microwave popcorn: butter, cheese, natural, and kettle corn. Describe a randomized block design for this experiment. Justify your choice. So they have 10 bags each. They have 40 bags total. So it makes sense to block by the number of, you've got 4 different types of popcorn there. So we're going to block by type of popcorn because we think maybe the butter and the cheese and the natural kettle corn would be similar to each other. And so that's a good way to block here. So 4 blocks. Randomly inside of each block, so there's 10 of each type of popcorn. You're going to randomly choose or assign 5 bags to get the treatment, the button, and then 5 will get the timed thing that comes from the box. So shake the box. So you don't have to number the 10 in each one if you don't want to, because they don't really have names. So you can just kind of put it in a hat or a box or something, shake it up to randomize, and then pick 5 of them to get the button, and then 5 of them get the timed amount that it says on the back. Repeat this process for the 3 remaining varieties. After popping each of the 40 bags in random order. So that's actually important to write. I like that they added in random order because, I don't know, just the temperature of the room, that it's just always a good idea to randomize when you can. So even though we split it up into 4 different kind of mini experiments, 4 blocks there, it's good to randomize. And so just randomly, do that when you perform each of those things, then compare the results for the 4 varieties. They mentioned that. So they said it's good to do that even after you designed it all to as much as possible. Do that. They said when the room temperature could be greater, so maybe you pop a lot of popcorn, the room temperature goes up, and that can make a difference in the number of unpopped kernels, potentially. Why is this preferable than a completely randomized design for this experiment? So completely randomized would not take into account the different types of popcorn, right? So if there's a difference, if the different types of popcorn varieties makes a difference, then it will be able to determine that. Maybe the microwave button's more effective for kettle corn, but not for butter, right? So there could be some interesting things that happen. Ooh, this is the number one thing I feel like. Don't mix the language of experiments and the language of sample surveys. You will lose credit if you say things like, use a randomized block, which is for experiment, to select a sample. Oh, we're not selecting a sample. We're assigning a treatment, right? Randomly. Or randomly assign the treatments using 3 different strata. No, we use 3 different blocks, right? So strata is for observational studies and samples. So we're not actually taking samples. We're randomly assigning treatments here to different blocks in that case. So it's just a language of this. Even better than block design can be match pairs. If you can do match pairs and this makes sense in the setting, ooh, this can be really good. And oftentimes, so match pairs is usually like you're literally pairing up the data. So you have to pair 2 very similar experimental units. So it could be, I've seen that where you pair it by age. So like the 2 oldest people together, 2 youngest people together, and everywhere in between. Identical twins would be ideal, right? That would be the ideal candidate for match pairs because they have the same DNA. If you do some kind of thing to one and do the treatment to one and the placebo to the other, like that would be a very good thing. So we do that with twins. It doesn't have to be that similar though. Oftentimes we even do match pairs design with yourself. So there's been many cases where let's say you're kicking a soccer ball, you want to see how far it goes or something, that you might do a left and right leg kick. So with yourself, like you actually, you're pairing with yourself, or like before and after. So like they might test your pulse rate and then give you some kind of drug of some kind and see if that affects your pulse rate. So that's like a before and after. That could be a match pairs design as well. So either pairing with yourself or another subject that's very, very similar in some ways to what you are. Sometimes you can't do match pairs. It doesn't make sense in every setting, but it's really good when you can. A consumer organization wants to know if using a certain fuel additive increases the fuel efficiency, miles per gallon of the car. So maybe 87 or 89 or 91, one of those octane levels. Or no, this is just additive. So they're actually, so additives are when you have that extra little thing from AutoZone and it says make your, get you the oil, the gas, everything runs better when you put in the additive. So they're actually going to test it and see if that's just, advertising or if it actually works. So they have a total of 20 different cars available for testing. Could you do a match pairs design? So these are just 20 random cars. So I don't know how to pair them in any kind of similar way. So I don't think we can do it that way, but maybe we could pair with themselves. So maybe you could do a tank of gas where you, don't have the additive, see how many miles it goes. And then you have a tank of gas with the additive and see how many miles it goes with the additive. So give each car both treatments in random order. So that's important too. So, you might want to give randomly. So you choose half of them get the one treatment first, half of them get the other treatment first. I'd like the placebo treatment first, that kind of thing. It's reasonable to think that some cars are more fuel efficient than others. So using each car as its own pair, oh, that's great. Yeah, because you have 20 cars in a parking lot, like 20 different types. Some are going to be like, Toyota Priuses, they get great gas mileage, and some might be like, a Hummer that gets terrible gas mileage. So, for that. They said flip a coin. You could also do rand int on your calculator. In this case, though, flipping a coin would be okay to use because if you flip a coin and one of them gets the treatment, the active treatment first, then by default, the other one will get the inactive treatment first. Or by default, by default, that would be the second one be first. So you could do it that way. You could also, sign it out differently using randint or something. For each car, record the fuel efficiency after using each treatment and then compare fuel efficiency with and without the additive for the 20 cars. So each car has 2 trials, right? They have one with additive and one without. You're comparing and seeing if it made a difference or not. So it's a great way to do the experiment. Each experimental unit oftentimes receives both treatments in random order. So I like the way they said that. The experiments will often have a washout period between the treatments, so the first treatment has no effect on the second. So if you put the additive in and you didn't use all your gas, that could be a problem, right? So they'll take all the gas out and then put a new tank of gas without the additive in there and do that. So that we don't want those residual effects of the additive. Okay, that's your lesson for today. This one is just some extra practice here. 2 students who sleep in want to find the quickest route to drive to school in the morning and return home in the afternoon so they can take a longer afternoon nap. That's important. So their morning commute during the rush hour and heavy traffic, but the afternoon commute isn't rush hour because school lets out earlier than most businesses. That makes sense. Students are considering 3 different routes and we'll test them for the first 3 weeks of school. Describe a randomized block study for this experiment. Justify your choice of blocks. So you have 3 different routes, right? You have different days of school. You have morning and afternoon. So how are you going to block this, right? So to me, I think I would do morning and afternoon. Let's see what they did. A randomized block accounts for variability. This at certain times of day, so morning and afternoon. So they blocked by morning and afternoon. That makes sense to me. This makes it easier to determine if one route is quicker than the other. So the morning gets all 3 treatments. The afternoon gets all 3 treatments there of the 3 different routes. There you go. Explain why randomized block design might be preferable to completely randomized. So if you did completely randomized, so if we do it on times a day, because the length of time it takes to drive a route is likely to differ by times of the day, right? So then we're comparing the afternoon easy commute to the morning tougher commute, that takes longer. So it's not really fair. So it's going to be better to block it out because there's definitely a difference in the morning commute and the afternoon commute. I like this example a lot. And it goes a little bit more into detail onto how you would carry that out. So I would read that, make sure that makes sense to you. In swimming, drag suits are specially designed swimsuits that have extra folds of fabric to catch more water and increase drag as athletes swim. Oh, so that makes you slower, actually. I didn't realize that. Okay, it takes me a second. This gives the swimmer a more strenuous workout during practice with the aim of making them stronger and faster. I like that. So 2 students on the swim team wonder if drag suits really do increase the time it takes to swim the 50-meter freestyle compared to regular suits. I think they would. A total of 24 students are on the team. Describe the experiment that uses a matched pairs design to investigate this question. So I would do matched pairs with themselves, right? Even though there's 24 different students, this makes sense to do. If you can do it with yourself, that's great. So they swim in a random order, once with this special suit and one with just a regular bathing suit. And they do their times and they compare them. So you block by using the special suit, I think. Let's see. Have each swimmer use both suits in random order. That's important, the random order. It is reasonable to think that some swimmers are faster than others, so each swimmer should be their own pair. Accounts for the variation in the 50-meter freestyle. For each swimmer, flip a coin. If the coin lands on heads, the swimmer will use the drag suit first and the regular suit second. If the coin lands on tails. So they specified what's going to happen with the coin flip. For each swimmer, record the time to swim the 50-meter freestyle in each type of suit. Then compare the time with the regular suit and the drag suit for the 24 swimmers. That's your lesson for today.